Welcome. In this video lecture, we will continue our module 2 on forecasting. So this is basically the part 4. So in part 3, we talked about regarding the naive forecasting method. Now in this video lecture, we are going to talk about the moving average based forecasting method. So talking about the moving average, we have the two type of method. One is called as the simple moving average, and another is known as a weighted moving average. The main difference is while we are applying the simple moving average, in this method we are going to give the equal weightage to all the number of periods we are considering in order to find out the average value. Okay, whereas in a weighted moving average, obviously we are going to give the different weights, which mean we can give the importance with respect to the weight to certain particular time period. And in majority of the case, the recent times are giving the more weights. But we will talk about this one later in more detail. So let's first of all discuss what is a simple moving average, under what particular condition we can apply the simple moving average, okay, as well as how we can apply this moving average using a particular data set. So before discussing the simple moving average, I can also let you know that as we have discussed in the last lecture regarding the knife forecasting method as well as the simple moving average method, both are methods are appropriate when we have the data pattern containing only the level pattern. Okay, if there is a trend pattern or if there is a seasonality also there, then these two methods are not more appropriate one. Okay, but as we have discussed, if you have only level plus seasonality, then you can apply seasonal knife. Okay, but the normal knife method as well as the simple moving average method are the appropriate one when you have the level pattern only in your data set. So first of all, the simple moving average is applied as I mentioned that if you have only the level pattern, which means if you have a stable demand over the average point, okay, so there should be no seasonality, there should be no trend. In that case, this method can be applied. Okay, so using different demand values, okay, of the recent period, it is going to develop the future forecast value, which means either it is going to be used two periods average, or either it is going to be used previous 3 periods average or 4 period or a 5 period. So depending upon how much number of periods you are going to use to get the average value in order to predict the future forecast value. Okay, so the mean idea in the moving average is, so the moving means every time we are going to find out the new forecast, we are going to drop one value from the oldest data point, and we are going to add the new observation or the new data point when we are going to calculate the moving average. So what does this mean? We are going to explain using a data set. Okay, so let's say we have this data set. So let me apply the 2 months moving average. So I'm using the same data set which we have used in the naive method. And then I will talk about this two, or either I should use 3 months, or either I should use 4 months, or either I should use 5 months. So how we are going to decide this number? So I will talk about in a minute, but let's first of all discuss how we can apply 2 months simple moving average. Okay, so because we are going to apply the 2 months, so that means the first 2 months are going to use to predict the third month's moving forecast value. Similarly, if I am going to apply the fourth, which means April's forecast, then the oldest data point is going to be removed, and then the new observation, which is the March value, is going to be added, and then using the February and March, we are going to predict the April. Same is the case in order to predict the May, we are going to remove the February value, okay, and then we are going to add the April value. So that means we are going to use these two values in order to get the math forecast. So how we can calculate? So this is a 2 months simple moving average. So that means 36 plus 42 divided by 2. Okay, so we are going to get the 2 months moving average for the month of March. So this is for the month of March. So for the month of April, how we are going to calculate? So we remove this 36. We included the new value, which is 56. So in order to predict the April forecast value using this method, so which is going to be 42 plus 56 divided by 2. And for the month of April, this is going to be the average of the next two, which is 56 plus 75 divided by 2. For the month of June, this is going to be 75 plus 85 divided by 2. Okay, this is going to be the forecast value. So now if I would like to predict the January, so it is going to be the average of the previous 2 months, which is double one triple one plus one double one zero divided by two. So that would be the forecasted value for the month of January if we are going to apply the 2 months moving average. So the rest of the things you already know, we have discussed in 2 or 3 videos how you can calculate and how you can calculate the mean absolute deviation, mean square error, as well as mean absolute percentage error. So I will calculate these values once again using the Excel. So first let's discuss if I would like to apply, instead of the 2 months, I would like to apply 5 months moving average. Okay, now in order to apply the 5 months, so that means the first five values we are going to use, okay, to predict the 6 months forecast, which means the June's month forecast. So this is going to be 36 plus 42 plus 56 plus 75, okay, plus 85 divided by 5. That is going to be the June's forecasted value. Now we are going to remove the oldest value and we are going to remove the next value, which is 95. Okay, then 42 plus 56 plus 75 plus 85 plus 95 divided by 5 would be the forecast value for the month of July. So once again, for the month of August, this is going to be removing the 42, adding this one. Okay, and then we are going to take the average of these values and we will get the forecasted value for the month of August. So now in order to find out the forecast value for the month of January, so this is going to be the average of these five values, okay, which is 108 plus 1011 plus 114 plus 111 plus 110 divided by 5 would be the forecast value for the January. Now the question is, should I use 2 months, should I use 3 months, should I use 4 months or 5 months? So how are we going to decide this number? So remember that if uh, there is a constant variation over the time, okay, so if there is a constant variation in your data over the time, use the large number period in order to calculate the simple moving average, such as 5 months, 6 months, or 7 months. But if there is not the large variations and it is not the constant over the if it is the variation is not constant over the time, there is a continuous variation is occurring and the pattern is changing over the time, then you can use always the smaller number, right? So remember that using the large number, it is going to be predict getting the future value is going to be more smoother value, which is going to be smooth as much as possible, which is going to produce smaller and smaller variation. But whereas using the smaller number is going to be basically picking the exact pattern and it will also generate the larger variation. So you will see that if we are going to use a smaller number in order to get the forecast value, it will always give us the larger variation forecast variations, okay, not in terms of error but overall the forecast variation due to the variations in the data. Whereas if it is a constant variation over the time, then the larger is going to be better method, and it is going to give us the overall forecast variation going to be lesser compared to the if we are going to use a smaller number of data points or number of you can say time periods to calculate the average. So the formula for the simple moving average we can write down this way, which is in order to predict the next time period forecast would be sum of the actual data points. So sum of actual data points depending upon what number of period you are considering. Whether you are considering 2 months, then we are going to add two values. If we are using 3 months, that is going to be three, as we have seen with the help of the example. Now let me apply these 2 months as well as 5 months in Excel, and then we will also compare the result of these two forecasting methods. Okay, so I'm going to use the same case study data. Okay, so in order to apply the 2 months simple moving average, what we will do, we are going to skip the first 2 months values. Okay, and then in order to calculate the average, what we are doing, as you can see that we are basically simply taking the average of these two. Okay, so either you can say that this plus this divided by 2, or either we can apply the simple average of these two, right? And then we can apply the average of the first value is going to be removed and the next value is going to be added, average of this two, right? So either you can use the average values, or either you can apply simply the addition divided by 2. So once we have done this, so we can simply drag and drop. Okay, so with the help of this one, we would be able to get the January 2020, the forecast value is 1011. Okay, so that means based on the 2 months moving average, the forecasted value for the month of January 2020 is 101. So once again, in order to calculate the mean absolute deviation, mean square error, mean absolute percentage error, we need to find out the forecast. So what is the formula of the forecast? Actual value minus the forecasted value. Okay, and then similarly, actual value minus forecasted value is this one. So we can simply drag and drop. Okay. And then in order to calculate the absolute error, we are going to apply the absolute function. Over here, once again, we can drag and drop. Okay, and then in order to find out the error square, so we are going to take this error square. Okay, the square of this value, and drag and drop. In order to calculate the absolute percentage error, what we will do, absolute error divided by the actual value. So we are once again going to get this absolute percentage. So once again, make sure you have selected over here is percentages values. Okay, we are going to use this column to find out the absolute deviation, which is basically the average of these absolute values. Okay, so this is basically the 7.2. Okay, 7.2 we are going to get. Okay, so similarly, the mean square error is the average of these data points. Similarly, the mean absolute percentage error is the average of these data points. So this is basically we are getting the average. And then once again, I am plotting on the graph. So after selecting this data point, so you can go to insert and then use the line mark in order to get. So this is a forecasted value we have. Okay, for the month of. So as you can see that we have also calculated the standard deviation, okay, so which is equal to STDEV, standard deviation of what? Standard deviation of this forecasted value. So the standard deviation of this 2 month simple moving average is 19.2. So keep this in mind. I will talk about in a minute. So why we have calculated this one. So let me apply on the same data set is the 5 months simple moving average. Okay. So once again we are going to skip the first five values in order to get the average. So we are going to sum these up divided by 5 as we have done over here. So in order to get the 5 month simple moving average, we are going to skip the first value, which is 36, skipping and adding the next value, which is 94. Okay, so 42 to this June, we are going to get the forecasted value for the month of July. So if I am drag and drop for the January, so this is the one period I had forecast using 5 months moving average. The similar way we are going to calculate the error, absolute error, error square, absolute percentage error, as well as these values, which is mean absolute deviation, mean square error, mean absolute percentage error, and then we are getting the standard deviation of the 5 months. So as let me go back to the PPT. So I have just picked the data of the graphs, okay, 2 months, 5 months, as well as mean absolute deviation, mean square error, standard deviation, same is the case for 5 months. If we are going to compare the measure of forecast accuracy, whether the 2 months moving average or the 5 months moving average is better for this data set. So for that, we are going to compare which method is producing lesser mean absolute deviation, which method is producing lesser mean square error. So the 2 months is producing smaller mean absolute deviation compared to 5 months, as well as smaller mean square error compared to 5 months, smaller mean absolute percentage error compared to 5 months. So as far as regard based on the measure of forecast accuracy, so the 2 months moving average method is better compared to the 5 months moving average method for this particular data set. So as we mentioned earlier, that the larger number we can use if your data set is more smooth, because it is going to produce the forecasting value which is more near to each other. Whereas if we are using a smaller number of months or number of data points in order to get the forecast value, it is going to be produce more variations forecast value. Okay, basically it is trying to follow the exact pattern, right? So which we can see that the standard deviation in the 5 months is smaller compared to the 2 months. Okay, because here we are using the larger number. But as far as the forecasting method is concerned, so in this case, the 2 months moving average is better compared to the 5 months moving average. I hope you got the idea. So thank you so much. See you in the next video in which we will talk about how we can apply the weighted moving average. Okay.